Alright, so this section we're going to go over factor theorem. And factor theorem is going to involve using synthetic division. So the main idea or the concept of factor theorem is one of the factors, meaning the divisors, is it a factor? So in order to prove that it's a factor, if the remainder is 0, then yes, it is a factor. If it's not, then it should not equal to 0. So let me rephrase. If the remainder is 0, yes, it is a factor, the one that you use in synthetic division. If the remainder is not 0, then the divisor that you use is not a factor. So we have, in our first example, f of x equal 2x to the fourth minus 8x to the third minus x squared plus 22x minus 8. Now, before I do any division, before I look into the divisor or factors, let me see if I have all terms. So I'm starting with the x to the fourth. So my fourth highest exponent is 4. So I'm going to count down by 1. So 3, I have it. 2 is there. And 1 is right here. So I have all my x's. I'm good with that. Now after x to the 1 power should be a constant number. So I have minus 8. So I'm good. I can move on to division. Now we have our two factors right here. X plus 1 and x minus 2. So on the left, I solve for x plus 1 where x equals negative 1. And then over here, I solve x minus 2 equal to 0. And then x equals positive 2. So first we're going to test out x plus 1 or the 0, x equals negative 1. So I'm going to put negative 1 here. Next, I'm going to fill in the L table with the coefficients from here. So 2, negative 8, so that's minus x squared, so that's going to be a negative 1, positive 22, and then a negative 8. So for our synthetic division, we always bring down the first number. So first number, so 2. Now we're going to use a different color. So our 0, negative 1, negative 1 times 2 is negative 2. So starting from the top, negative 8 minus 2, because that was negative from the beginning. So negative 8 minus 2, that's negative 10. Negative 1 times negative 10 is just a positive 10. So negative 1 plus 10 simply is 9. Now negative 1 times 9, that's going to be a negative 9. Alright, so 22 minus 9 is going to be a 13. And then negative 1 times 13 is negative 13. Negative 8 minus 13, well, that's just negative 21. And then this is our remainder. So since our remainder is not 0, we tested out negative 1, which came from x plus 1. So therefore, I'm going to write right here, x plus 1 is not a factor. It is not a factor. So again, since your remainder did not equal to 0, x plus 1 is not a factor. Alright. Now we're going to test out the second factor, x minus 2, where x equals to 2. So our next 0 or solution is 2. We're going to see if that is a factor. Or, in this case, a 0. So x minus 2 is a factor. We're going to test if it is a factor. Meaning we're going to test if this is a 0. So basically, we're using the same coefficient from the same problem. So 2, -8, -1, 22, and -8. And of course, first step, bring down the first number. Alright. Same process as always with synthetic division. 2 times 2, that's just positive 4. So -4 plus 4 will become -4. Then 2 times -4, again, 2 times -4, that's -8. -1 minus 8, that's -9. And then I'm doing 2 times -9, that will become -18. So 22 minus 18 will be simply 4. And then 2 times 4, that's going to be a positive 8. So -8 plus 8, that's a 0. So this is our last number, our remainder. So since our remainder equals 0, we test out 2 are 0. Therefore, x minus 2 is a factor. So I'm going to write right here, x minus 2 is a factor. So here, in this example, x plus 1 is not a factor, and x minus 2 is a factor. Now, when you have two factors, it is best that you test out both of them, not just one. So if, say we tested out x minus 2 first, and this was a factor, does not mean that you can just stop. You actually have to check if the other one, x plus 1, was a factor. But in this case, we tested out and it was not a factor. So that's alright. This one, x minus 2 was a factor, x plus 1 was not. For example 2, we're still doing factor theorem, so our function, our problem is 10x to the third minus 7x squared minus 3. So again, 10x to the third minus 7x squared minus 3. So for any division problem, before we do anything, we gotta make sure all the terms are there. So our highest exponent is 3. So we're going to count down by 1. So after 3 is 2. It's there, so we're good. Now after 2 is 1. So x to the 1 power. I don't see it. So that means we're missing it. So I'm going to rewrite it right here. 10 x to the third minus 7x squared. Now the one we were missing was x to the 1 power. So since it was not there, I'm going to put plus 0x, and then we have a constant number, so bring that over here. So minus 3. So let's check. 10x to the third, 3, minus 7x squared, 2, 0x, 1. Alright, we got all the x's, and now we have a constant number. So we're good. Alright, and our question is to test out if x minus 1 is a factor and if x plus 1 is also a factor. So again, the possibility is if one of them is a factor, or both of them is a factor, or none of them are factors. So again, three possibilities. One is a factor, both of them are factors, or none of them are factors. Alright, so I did x minus 1, set it equal to 0, solve for it, and x equals 1. So I'm going to put 1 right here. And then I'm going to use the coefficients from the problem. So 10. And then, since it's minus 7, so negative 7. And then 0. And then, since it's minus 3, so negative 3. Alright. First step is synthetic division. Always bring down the first number. So that's 10. Alright. So let's check. 1 times 10, that's just 10. And then negative 7 plus 10 would be a 3. 1 times 3, I'll put it right here. And after that, 0 plus 3 because it was positive, so that's just 3. And then 1 times 3 again will be 3. And then negative 3 plus 3 will be 0. So 0 is our last number, therefore it's our remainder. Since our remainder equals 0, that means x minus 1 is a factor, or 1 is a 0. So I'm going to write right here, x minus 1 is a factor. Now, since I tested out the first one and it was indeed a factor, when we're going to test out this one right here, what you can do is you can use the same numbers, 10, negative 7, 0, or negative 3, or you can use 10, 3, 3 over here. Let's work. So, since the first one I tested out, x minus 1, is a factor, that means we can test this one out. Since this is a factor, we can use this over here. Now first, we're going to test out x plus 1, which x equals negative 1. So I'm going to write right here, negative 1. Now, you could use these numbers over here, but you might do like one more step. Over here, since x minus 1 is a factor, you could use these numbers instead. So instead of this one, you can use these. But the condition is if the one you tested out was indeed a factor, you can use it. If not, you have to use this. So again, if it was not a factor, you have to use these coefficients to test out the second factor. But if the first factor is indeed a factor, then you can use these numbers right here. So x minus 1 was a factor. I'm going to use 10, 3, and 3. 10, 3, and 3. And of course, first number, bring it down. So 10. Alright, so negative 1. Negative 1 times 10, that's negative 10. So 3 minus 10, that's negative 7. And then negative 1 times negative 7, that's just a positive 7. So 3 plus 7, that's a 10. That's our last number, so therefore, our remainder equals 10. So, since our remainder did not equal to 0, therefore, x plus 1 is not a factor. So I'm going to write x plus 1 is not a factor. So x plus 1 is not a factor. But x minus 1 is a factor. Now let's review. Since the first factor, x minus 1, we tested out, and the remainder equals 0, okay, that means when we test out the second factor, we can use these numbers right here, over here, instead of these 4. Now, if you choose to use these 4 numbers from the original problem, then instead of just the 10, you might get a different remainder, and for sure, it won't be 0. Since we just tested this one out, x plus 1, if you use these coefficients instead, when you test out x plus 1, it will still come out as not a factor, and your remainder will not equal to 0.